Hello, today I want to talk about conditional GAN. In my previous video, I talked about vanilla GAN that you input the random input like here in the generator. You input the random input, and from this random input, it will be outputting an image, right? But it's only a single type of image. What if you want to produce more than one image? Like, for example, in case here. Oh yeah, in my previous video, I produced this bukan image, right? But in this video, I want to produce three images. So here, I'm using the three images. First, kobokan, the Una, it's Oli. And because my machine is not so powerful, I reduce the image to only this. So to only black and white image. So it's only a silhouette. This is the silhouette for the Oli. Instead of using here 799 times 800 pixels, I resize the image to here 28 times 28 pixel. And if you curious about the script that I'm using to resize the image, oh yeah, for the silhouette, I'm using the GIMP. So I edit it manually, and to transform the image to to resize the image, I'm using this script. I'm just using OpenCV 2 and resize it to the 28 times 28. Okay. Now let's move on to the main script. Okay. Here the model script. Here this is the same in my previous video. The height and the width is 28 times 28. This is for the length of the random input. I'm using 100. This is the bed size. This is the learning rate, and this is the train A port. I'm using 200. And same as the GAN, here we also have a generator and discriminator. And what the difference between this conditional GAN and the vanilla GAN? Here you can see here we have two input here. The input, as you know, the input in here is just a random value, and here the label. And the label here is just to signaling the model that for example, here we have three images, right? So we will using the one hot encoding. For example, in this case, I am using code 100 for Muna and 010 for Kobokan and 001 for Oli. And when I input this signal plus here the generator, you can see here I concatenate the input vector and the label vector or the signal vector here. This generator will produce the image that we want. Oh yeah, I forgot to mention, but actually this is not my original script. I adopt this from this. I adopt the script from this GitHub page, and for the detail I'm using here conditional GAN here, but I modify some of the part of, for example, in here in the generator in the original script, the last activation function is tangen hyperbolic, but in my script I modify it to using sigmoid. Now you may be asked why I am saying the tangen hyperbolic to the sigmoid. It's because I normalize the script No, the value of the image. I want to show you where I'm doing the normalization here. You know that the image, the highest value from the image when we read an image like this, it will be 255. So I just normalize the maximum value will be 1 and the zero value will be same 0. Okay, and as you know, the let me Google about the tangen hyperbolic and sigmoid. As you can see here, if we using the tangen hyperbolic, it will be mapping the value from -1 to 1, and it's not matching with this, right? Because the minimum value in this case is 0 and the maximum is 1. But if we look at the sigmoid, you can see here it mapping the value from 0 to 1. So it's matched with our case. That's why I think that you can see here, yes, we concatenate, and after that, yeah, the only difference is just here. Oh yeah, I forget. Here we expand the feature from 3 to 256, and also for the random input we also expanded to the same number, 256. After that we doing the regular feed forward operation, and you can see here we also using the batch normalization, and after that the output will be processed by the sigmoid, and we will have a final step is 784. If you divide it like this is the multiplication. This is the result of multiplication of 28 times 28. So if we from the flat value, if we change it to the 2 dimension, it will be matching with the dimension of the expected image. Okay. Now for the discriminator, I think it's same with the vanilla GAN, because as you can see here, the final output will be 1. Here, FC4, the final output is just 1. It decides if this is the image real or fake. Oh yeah, and there's another unique treatment in the script. Here we init the way with some custom function. Here we define the mean and standard deviation, and then we also define the betas, and here this is the process for the training. Oh yeah, as you can see here, when the efforts reach a certain value, for example, in this case is 30 and 40, the learning rate will be changed and it will be divided by 10, as you can see here. So when it reaches 30, it will be 0.00002, and when it reaches 40, it will be reduce it to the 0.0000002. And as you can see here, for the discriminator loss, this is same with the vanilla GAN that I already explained, from the real image and the fake image. And for the generator loss is how much the generator can trick the discriminator here. So we're using one labels here. And then after that, here I'm in the for the original script I create this new function. This is for show result. Here show the result. So output will be like this. Here we can see the progress how the AI learn. So this is for the epoch 1, epoch 2, epoch 3, epoch 4. You can see here in the earlier the image is just a random noise, but it leads a certain epoch. You can see here the silhouette is formed this, and it's getting better when the epoch going up. But yeah, but there's nothing change in particular because I think this is just the fun. I think this is just good. There's no need for improvement. So that's why there's no any major change when the efforts increase when it reaches this when it reaches the efforts above 100. After that I set the model in here, model final. Actually we can run this, but since the since the script will be take a long time to run, that's why I show you the result. And also the output of the script is this error graphic. And here, this is the graphic for the error of the generator and discriminator. And as you can see here, in the earlier epochs, the discriminator error is going down, and in the other hand, the error for the generator is going up. And as you can see here, after that, they both is going down here, but yeah, because their work, yeah, because their job is opposite of each other, their error looks like they'll never meet. I already built the script to produce the image using the trained model. As you know, we can determine the picture that we want to produce, right? So for example, we want to produce Kobokan. So we will using the code 010. Let's try. Okay, done. And as you can see here, we have a silhouette of Kobokan. And this is the real silhouette here. Quite same, right? Yeah, because the training data literally almost same. I just in the vanilla gun in my previous experiment, I just add some random noise here. So that's why in my gun here, it's different with the gun that you found in internet that it will produce a new fresh image. No, this is different because I only use same image, so the model can produce a new image because yeah, it's only have one image actually. And what if we want to produce Mona? So it must be 100. And here we have Mona 0. Now what if what if the user input the signal like 110? As you know, we never train the model to process the input like this, right? But let's try what it will be. What if we using this? Okay, done. Look, this is quite interesting, right? As you can see here, we have a combination of the image of Mona and Kobokan. As you can see here, we have the wavy hair of Kobokan, and we have the silhouette of Mona in the center, right? So now, what if we combine all of them. All of them will be 111. Produce. Now it's something looks like the combination from all of them, right? You can see here we have a little silhouette of the sword from the Oli. Yeah, because the hair of the Oli is white mesh, that's why we have a result like this. Now I'm curious, what if we input all of them to 0? What we will produce? If we doing all of them to 0, we also have the combination of the image. And yeah, I think that's all. I think it will be more interesting if we using the colored image, but I'm too lazy to modify the script to make it read the colored image and run this in the Google Colab. And then after that, I download the result. It's too much work. I have another experiment in my mind, so I think for this is enough. Okay, I think that's all. So in the another video. Bye.